Alright, this video will run through a quiz about graphing rational functions. So here in problem number 1, we're given a rational function that has already been graphed, and we're asked some questions about it. So let's talk about the vertical asymptotes. We have one here at -1 and another one at +2. So we will call them x equals -1 and x equals 2. Don't just say -1, don't just say 2, say x equals -1 and x equals 2. There's also a horizontal asymptote here on the x-axis. That is the line y equals 0. Now let's talk about the domain. The domain is the x values of a graph. So it's how far the graph goes from left to right, all the x values of the graph from left to right. So, alright, we've got this portion of the graph, but on the x-axis it goes from -infinity to -1. So the first part of the domain goes from -infinity to -1. We'll leave that round because you can't touch the asymptote. -1 is not included. Union. Now we're looking at this portion of the graph. Okay, but looking at the x-axis, it goes from -1 to 2. So that's the next part of the domain, is from -1 to +2. Okay, now let's look at this portion of the graph, but on the x-axis it goes from 2 to infinity. So we'll put 2 to infinity. So that's the domain. Now for the range is the y values. Okay, so if you look at the graph, if you look at just the middle piece, for example, alright, you'll notice that just this part alone contains every y value from -infinity to +infinity. So when you're doing the range, you can't really look at one of these branches at a time, because when you look at, for example, this, when you look, for example, at this y value, you're hitting two different parts of the graph. So we're hitting y values everywhere. It's just that sometimes we're hitting more than one. But anyway, even just the middle portion shows you that it's going from -infinity to +infinity. So that's where we're going to put for the range. It's -infinity to infinity. Now let's talk increasing and decreasing. Okay, when you're doing increasing and decreasing intervals, you are scanning from left to right across the function. And from left to right, this portion of the graph is decreasing. It's going downhill. Now, when I write this interval, though, I'm only talking about x values. So let's just only look at the x-axis. So this portion of the graph on the x-axis goes from here to here. That's -infinity to -1. Alright, so when you write these down, make sure you're only looking at the x-axis. Okay, so we have a decreasing interval that goes from, I put that up like I was getting ready to write on increasing. We have a decreasing interval from -infinity to -1, and we'll leave it round because it doesn't reach the asymptote. Okay, next we are looking at, it jumps to here and does this. Now this is also decreasing. The entire way of this middle part is going downhill. Alright, so that portion of the graph is decreasing. And again, we're only talking about the x values. So looking at the x-axis, this portion of the graph goes from -1 to 2. Okay, so we'll have another decreasing portion from -1 to 2. Now let's look at the last portion of the graph. Alright, because then it jumps up to here and it is decreasing again. And that portion of the graph, looking at the x-axis, goes from 2 to infinity. So that's another decreasing portion of the graph. So I'm going to say union 2 to infinity. So the entire graph is decreasing, so it makes sense that the decreasing intervals should match the domain, because the entire graph is the domain. So it's all decreasing. So for increasing, we'll just say none. There are no increasing intervals. Okay, now let's talk about end behavior. End behavior is always going to match the horizontal asymptote. See how we have y equals 0? Because when you're talking about end behavior, you're just talking about what is happening at the ends of the graph, the far left and the far right. Okay, so when we talk about as x approaches negative infinity, we're saying as we go towards the far left. And as we go towards the far left, we're approaching the asymptote. We're approaching 0, the horizontal asymptote, not a coincidence. And as x approaches positive infinity, that means as we go towards the far right. As we move towards the far right, we are again approaching the horizontal asymptote. We are again approaching 0. So these are always going to match the horizontal asymptote. Okay, for problem number 2, we're supposed to make a graph of this function and fill in this information. So I like to start with the vertical asymptote. We know that the vertical asymptote, you set the denominator equal to 0. So if we set x plus 2 equal to 0, we're going to get x equals negative 2. So one asymptote will be x equals negative 2. Obviously that is a vertical asymptote. So let's go ahead and graph that. Alright, so x equals negative 2, so we have a vertical asymptote here at negative 2, dotted line. Okay, now let's talk horizontal asymptote. Okay, so for a moment, imagine that we didn't have the 3 there on the end. If we did not have the 3, then we would use our 3 rules for finding a horizontal asymptote. So what is the horizontal asymptote? Well, we need to talk about the degree of the numerator compared with the degree of the denominator. If the degree of the numerator is less, then the horizontal asymptote will be y equals 0. If the degree of the numerator is equal to the denominator, then we make a fraction out of the leading coefficients, and that'll be the horizontal asymptote. If the degree of the numerator is greater, then there is no horizontal asymptote. So let's see which situation we're in. So we have a constant in the top. Alright, that means in the numerator we have degree 0. This x in the denominator means we have degree 1. So the degree of the numerator is less, so that means the horizontal asymptote of this function would be y equals 0. But we have this extra number on the end. That has the effect of moving the graph up 3 units. If you take an asymptote of 0, that's the x-axis. If you move it up 3 units, 1, 2, 3, then you are here. Okay, so the horizontal asymptote, because we do have this plus 3 on the end, the horizontal asymptote will actually be y equals 3. Okay, so y equals 3 will be the horizontal asymptote. Okay, so let's find the x and the y intercepts. When you have an extra number on the end like this, the way you will find the x-intercept will be to set the entire function equal to 0 and solve. So if I take negative 1 over x plus 2 and plus 3, set all of that equal to 0, when I solve this, I will have the x-intercept. So I would start by subtracting 3 from both sides. So I will have negative 1 over x plus 2 is equal to negative 3. Now I'm going to think of this as negative 3 over 1, and then I will cross multiply. Okay, if I do this diagonal right here, that's negative 3 times x plus 2. If I do this diagonal right here, then negative 1 times 1 is just negative 1. Little distributive property here. I've got negative 3x minus 6. If I add 6 to both sides, so that's negative 3x is equal to 5. And if I divide both sides by negative 3, I get x equals 5 over 3, negative 5 over 3. Do not make this a decimal. Leave it as a fraction. So, so my x-intercept will be negative 5 over 3, comma 0. All right, for the x-intercept, you're going to have an x value, and the y value will be 0. For the y-intercept, you're going to have a y value, a non-zero y value, but the x value will be 0. Okay, so finding the x-intercept was the harder part. Finding the y-intercept is easy. We can just put this function in the calculator and go to 0. So we go to the table feature and we type it in. So I'm going to hit the fraction button. I've got negative 1 over x plus 2, and that's going to be plus 3. So there we have it. Hit enter. We could use the table feature, or we could do ask x. It doesn't really matter for this. Especially if you start at 0, it doesn't matter. Okay, so at 0, we have 5 over 2. So 5 over 2 is going to be the y-intercept. So 0, comma 5 halves. So that's the x and y-intercept. Now let's plot these points. Okay, so as long as I'm in the calculator, take a look here. If you hit the toggle key, it shows you the decimal is 2.5. Okay, so this is the same thing as 0, comma 2.5. So I'm going to plot that point right now. Maybe I'll make it blue. Okay, so 0, comma 2.5 would be right here. So that's my y-intercept. And how about negative 5 over 3? Alright, so negative 5 over 3. Toggle it. So that's negative 1.6 repeating. So I'll think of that as negative 1.7. Okay, so this is negative 1.7, comma 0. So negative 1.7 would be about here. Alright, so there's my y-intercept and there's my x-intercept. Alright, let's go ahead and plot some additional points and sketch the graph. Now, when I'm picking my points to put on my x-axis, I focus on the vertical asymptote. So since my vertical asymptote is at negative 2, okay, so I've got my vertical asymptote here at negative 2. The values I'm going to put on my table, I'm going to go to the left and right of negative 2. And I always start out with values that are 0.5 to the left and 0.5 to the right. So if I went 0.5 to the left of negative 2, that would be negative 2.5. If I went 0.5 to the right, that would be negative 1.5. So I'm definitely going to include those. Now I'm going to go even further to the left and right. So this would be negative 3, and this would be negative 1. I need at least these 4 values. See, how much space do I have? 1, 2, 3, 4, 5. So I'll just go out one more time. So if I went to the left again, that would be negative 4, and to the right again would be would be 0. So these are the 6 values I'm going to use. So I've got negative 4. All right, I've got negative 4, negative 3, negative 2.5, negative 1.5, right? Negative 1 and 0. You know what? Maybe I'll just divide this last. These squares are pretty big, so I'll just split them up and put negative 1, and I'll squeeze in 0. Okay, so now I'm going to get the y values that go with these x values. And for that, I like to do ask x. So I've already got this in here, but I'm going to switch from auto mode to ask x mode. Okay, so let's see. I've got negative 4 and negative 3 and negative 2.5. Okay, and let's see. 7 over 2 is 3.5. Okay, so I've got 3.5 and 4 and 5. Okay, so now I've got to do negative 1.5, negative 1, and 0. Okay, so I have 1, 2, and 5 over 2. Okay, so I've got 1, 2, and 5 over 2, which we already discovered was 2.5. And we've already just plain plotted that. That was our y-intercept. Okay, so I'm going to plot the rest of these points, and I'll be ready to draw the graph. Okay, so negative 4 is at 3.5. Okay, so here's negative 2, negative 3, negative 4, and it will be 3.5, which is here. Okay, negative 3, comma 4. So negative 3 is at 4. Negative 2.5 is at 5, so this is negative 2.5. This is at 5. Okay, so we can really see the curve happening there. And then at negative 1.5, we're at 1. So this is negative 1, so negative 1.5, and we're up here at 1. Okay, and then at negative 1, we're at 2. So negative 1, comma 2. All right, so these 4 points, including the x and y intercept, you can see a nice curve happening there. All right, so that's plenty to enable us to draw the graph. Okay, so the function is going like this. Wait, I'm missing. Let me try that again. All right, so that first branch is going to look something like this. Even though it looks like it's touching the asymptote, because ink has thickness, in your imagination, understand that it's getting closer and closer to the asymptote without ever actually reaching it. And it's going to do the same type of thing over here. It's going to, it's going to look like you're tracing the asymptote, but really, you know that it doesn't touch. Alright, so your right branch should look something like that. Now we're ready to talk about the domain and range. Alright, the domain is it's the x values of the graph. So we're looking at the graph from left to right, and we're seeing what are the x values. So this first branch of the graph, goes from here to here, but on the x-axis it goes from here to here. So that's going to be the first part of the domain, not including -2. So that upper left-hand branch is going from, is going from -infinity to -2. Okay, leave it round because you can't include the asymptote. Union. Now this lower right-hand branch is going from here to here, but on the x-axis, if you just look at the x-axis part, it's going from here to here. So it's going from -2 to +infinity. So that's the other part of the domain. Okay, now let's talk about the range. Now the range is the y values of the graph. So as we go from bottom to top, which is how you should always do the range, from bottom to top, we first reach this lower right-hand branch. Okay, now looking at the y-axis though, this lower right-hand branch goes from -infinity up to 3. Alright, that's how high it goes, from -infinity to 3. So that'll be the first part of the range, will be from -infinity to 3, not including the 3. But then it picks up from here and goes up. And again, looking at the y-axis, it goes from 3 to +infinity. So that'll be the second part of your range, 3 to infinity. And that is it for problem number 2. Okay, now problem number 3 is another graph. Let's start with the vertical asymptotes. Alright, now for the vertical asymptotes, we have to set the denominator equal to 0. So if we set x² minus 4 equal to 0 and solve, I would factor this. It's the difference of two squares, so x plus 2, x minus 2. Set both of these equal to 0. And you get x equals -2, x equals +2. These are your vertical asymptotes. Okay, so let's go ahead and graph those vertical asymptotes as dotted lines. So there you have your vertical asymptotes. Now for the horizontal asymptotes, we have to ask ourselves about the degree of the numerator compared with the denominator. If the degree of the numerator is less, then the horizontal asymptote will be y equals 0. If the degree of the numerator is equal, then we do a over c, leading coefficients. If the degree of the numerator is greater, then there is no horizontal asymptote. Alright, you have to have these rules memorized. Okay, so in this case, the degree of the numerator is 1, because this is just a plain x. This is x squared, so the degree of the denominator is 2. So, since the degree of the numerator is less, that means the horizontal asymptote is y equals 0. So let's go ahead and graph that right now, horizontal line. And there we go. Alright, next they're calling for the y-intercept, so might as well do that now. Y-intercept is easy. Just put the function in your calculator and check it out. So you hit the table button. Alright, fraction mode. So I have x over x squared minus 4. I'm just going to go straight to ask x mode this time. Alright, if I want the y-intercept, I will put in 0 for x. Oh look, 0, comma 0 is the y-intercept. And I might as well graph that, yeah? So boom, that's my y-intercept. Now how about the x-intercept? Well, as long as there's no extra number hanging on the end, like the last problem had, can I look at it real quick? When you have the 3 on the end, an extra number, you have to set the whole problem equal to 0. But if you don't have any extra number on the end, then all you have to do is set the numerator equal to 0. Okay, and the numerator is just x. So if I set x equal to 0, then I'm done. That's telling me the x-intercept is, the x value is 0. Of course, the y value of the x-intercept will always be 0. So that's it. The x-intercept is also 0, comma 0, and we've already graphed it because of the y-intercept. Okay, we're going to have to skip the increasing, decreasing part for now because we have to have the function first. So in addition to the intercept, the x and y intercept, let's plot a bunch of more points and see what we've got. When it's time to pick which x values to use, it's all about the vertical asymptote. Okay, and here I've got two vertical asymptotes, -2 and +2. So every vertical asymptote is going to give me 4 values to plot. And here's what I mean by that. So I have a vertical asymptote of -2. That's going to give me 4 values. I have a vertical asymptote of +2. That's going to give me 4 values. So if I look at the -2, my first 2 values are going to be the numbers immediately to the left and right of this. Now I want to use decimals, so I'm going to go 0.5 to the left and 0.5 to the right. So I will have -2.5 and -1.5. Now I'm going to get another 2 values by going further. So I will have -3 and I will have -1. So I've got those 4 values so far. Now I'm going to get 4 values from the 2. If I go to the left and right of 2, I'm going to get, and again, decimals, 0.5 to the left, then I've got 1.5. 0.5 to the right is 2.5. Now I'm going to get 2 more values by going to the left and right again. To the left of 1.5 is 1, and to the right of 2.5 is 3. So I will have these 8 values, the pink one, ignore the asymptotes themselves. Looking at the pink numbers, I have 8 values. Now let me see how many spaces I have on my chart to see if I need to add some more in. 1, 2, 3, 4, 5, 6. Okay, I really need 8 to accomplish what I need to accomplish. So I am going to add in 2 extra values. So if you were taking this quiz, I would just draw extra boxes on the end to make room for the 8 that you need. Just add them on the end. Okay, but because I'm doing this on a computer, I can just add them in. So that is what I'm going to do. Okay, so magic. 1, 2, 3, 4, 5, 6, 7, 8. So now I've got my 8 that I need. So I'm just going to copy those onto my chart now. So I've got -3, -2.5, -1.5, -1, 1, 1.5, 2.5, and 3. Okay, so I need all the y values that go with these 8 x values. And I'm going to find them using my TI-30. Okay, so I've got -3 and -2.5 and -1.5. Alright, you can only put in 3 values at a time, so let's deal with this. Okay, so using my toggle key to help me with the decimals, this first one is -0.6. And the next one is -1.1. I'm just rounding to 1 decimal place, so -1.1. And the last one is -0.9. No, wait. Positive 0.9, not negative. Okay, let's do the next 3. So I've got -1, +1, and 1.5. Alright, so I've got 1/3, which I know is 0.3. And I've got -1/3, which I know will be -0.3. And I've got -6/7, which is -0.9. Alright, now I've got 2.5 and 3. Okay, so at 2.5 I'm looking at 1.1. And at 3 I'm looking at 0.6. Alright, so these are my 8 values, and I need to plot them all. So I'm going to do that off camera. So I'm going to take these 8 points, and I'm just going to plot them on the graph. So here I've graphed the 8 points in pink, and so here's what that looks like. So that's enough information for me to draw the curves. Let's see, let me make this a little stronger. So I'm going to draw these curves through these points and approaching the asymptotes on either side. So your first branch should look something like that. Now the middle branch, notice how you've got on the left, these 2 points are above the x-axis, and on the right it's below. So clearly it's crossing through the x-axis. We even had the x-intercept here at 0, 0. So that might make you nervous because you're thinking, wait a minute, I thought this was an asymptote. You're not supposed to touch it. You're not supposed to cross it. Well, that's definitely true when you're talking about vertical asymptotes. You never touch a vertical asymptote and you'll never cross it. However, horizontal asymptotes are really just there for the end behavior. On the left you see the graph is approaching that asymptote, but in the middle you will often cross or touch the horizontal asymptote. So that's what's happening here. Don't be alarmed by that. So this graph by the time it gets to the end, it's going to appear to be tracing the asymptote, even though in our minds we know it's not really touching. Okay, so that should look something like that. And then this branch, okay, that's not good enough. I knew I should have drawn this off camera. This is really tough to do with an electronic pen, you guys. Alright, so your graph should look very much like this. Now we can do the increasing, decreasing part. So when you're talking about increasing and decreasing, you are scanning across the graph from left to right. Okay, so let's see, increasing and decreasing. So first we come to this part of the graph. This first branch of the graph is decreasing because of the way it is going downhill, all right, from left to right. It's decreasing. But we are only to speak of the x values when you write down these intervals. So this branch of the graph that we get to first goes from negative infinity to negative 2. That's what you put down, just the x value. So just look at the x-axis. Okay, so that was decreasing from okay, that's too thick. So negative infinity to negative 2. Next, the graph jumps up here and does this. Swoosh. That is going downhill. But we are only to look at the x values that are covered by this graph. So looking at the x-axis, this swoosh goes from negative 2 to positive 2. Alright, so that's another decreasing interval from negative 2 to positive 2. Okay, now looking at the third branch, it goes alright, it is again decreasing from left to right. But again, we are only going to write the x values of that. So if you're staring at the x-axis, it goes from 2 to infinity. That portion of the graph goes from 2 to infinity. So that's what we'll put down for the final decreasing interval. Okay. There were no increasing portions of the graph, so we will just say none. And I think we've answered everything that we were asked for problem number 3. Okay, so let's move on. Now we're supposed to write a rational function with vertical asymptotes -4 and +4, and horizontal asymptote y equals 0. Okay, so let me get this straight. We need vertical asymptotes x equals -4 and x equals +4, and we need horizontal asymptote y equals 0. Yeah. Okay, so we know that you get the vertical asymptotes by setting the denominator equal to 0. So I need a denominator that will give me these solutions if I set them equal to 0. Well, let's start by looking at the factors that would give me these solutions if they were set equal to 0. So a factor of x plus 4 would give me a solution of -4. A factor of x minus 4 would give me a solution of 4. So again, the vertical asymptote comes from setting the denominator equal to 0. So if I had a denominator that factored to x plus 4, x minus 4, that would give me the vertical asymptotes that I want. So I really want this as a polynomial, though, in standard form. So let's go ahead and multiply these out. And if you multiply these out, you're going to get x squared minus 16. This is the difference of two squares. So you know that if you have x squared minus 16, that will factor as x plus 4 times x minus 4. Or you could have sat here and multiplied it out. You could have FOILed it, and it would give you x squared minus 16. Okay, now what about the other part? We need the horizontal asymptote to be y equals 0. So if we want the horizontal asymptote to be y equals 0, according to the three rules, to be y equals 0, the degree of the numerator has to be less than the degree of the denominator. Okay, so we just need a numerator that has a smaller degree than this. So the degree of the denominator, this is degree 2 because of the x squared. So we just need the numerator to have degree 1 or degree 0. Okay, so really you can put anything up here that you want as long as it has degree 1 or degree 0, and then you're okay. So you could put x up here, alright, because that has degree 1, or you could put a constant up here because that has degree 0. So I could put like a 3. Okay, so you could just put anything up here. So I'm just going to write anything degree 1 or 0. Okay, and that would be a rational function that would satisfy these criteria. Alright, so there's many correct answers for this problem. And I think that was the end. That's the end of the quiz. I hope this video was helpful.